Hackaday commenters must be happy because this time I decided to ditch the Arduino and use the classic 555 timer to solve a problem. I was asked to make an alarm that would go off when some kind of door or lid is opened, and extra request was to make the sound more noticeable in noisy environment, so not just a constant tone but modulate it somehow, changing the frequency or cycling it on and off. That would be easy to do with Arduino and couple lines of code, but should we waste Arduinos in such simple projects? Let's build this project using 555 timers, but before that I got something in the mail. Sponsor of this video, PCBWAY.com, offers PCB starting from $5 plus shipping. They also do 3D printing, CNC milling and other manufacturing services. My latest order, which I have just received, had something else though. These are parts from their module store. I got myself some Raspberry Pi Picos and some modules for upcoming projects. You can use money or their some kind of bonus points called beans to buy items from the module store. If you include PCBs or other manufactured things in the order, at least usually they will be shipped together. For up-to-date information on their services and pricing, go check out PCBWAY.com. This door alarm project can be divided into 3 different parts. First one is the main tone generator or the oscillator. Second one is modulator that will turn it on or off. And the third one is the sensor or other input that enables the alarm. For generating 50% square wave, my favorite 555 timer circuit is this single resistor circuit. In this, pins 2 and 6 are tied together. Timing resistor is connected between these pins and the pin 3, the output pin. Timing capacitor is connected from these pins 2 and 6 to ground. 555 timer's working principle dictates that when voltage on pin 2 goes below 1/3 of the VCC, pin 3 goes high. In this case it will start charging the capacitor, rising the voltage at pins 2 and 6. And when the voltage on the pin 6 goes above 2/3 of the VCC, pin 3 goes low and capacitor starts discharging. And that is infinite loop. Usually pin 8, the VCC, is connected directly to pin 4, the reset pin. This time I'm using pull-up resistor instead, because I need to be able to pull that pin 4 to ground when cycling the generated tone on and off with second 555 timer. I have this small beeper that I'll use as an output. I'll just add DC blocking 10 microfarad capacitor between pin 3 and the positive of this beeper. Negative side goes to ground. Now if I connect the power, I should hear solid tone. Just like that. After making this first oscillator with output in kHz range, I will make another one, but with timing components that set the output frequency to just a couple of hertz, or even less. By connecting the second oscillator's output to first one's reset pin, the tone will change to beep, beep, beep instead of constant tone. Other option would be to connect the resistor in kilo-ohm range from second oscillator's output to first 555's pin 5, the control pin. That would alter the internally set parameters of the 555, causing the frequency to change depending on the state of the second oscillator's output. I decided to go with the first option, the pulsed tone. At the moment, this circuit outputs that pulsed tone always when the power is turned on. Connecting some kind of switch or digital sensor to pin 4 of the second 555 timer controls the tone on or off. When that pin is pulled low, tone is off, and when high, tone is on. Let's say there's a magnetic switch that is closed when door is closed and opens when the door opens. I can simulate that with momentary switch connected between pin 4 and ground. Pulsed tone starts when I release the button, simulating the alarm when door or lid opens. I have a couple more 555 timers left, so who knows what we will do with them in the future. This was a successful project. See you next video. Thanks. Bye.